So now we go to our topic, which is this black box testing. So guys, we back to the big picture of the testing techniques. So previously we talk about this part, which is static testing, and we say this static testing doesn't require executing the code, executing the application, right? Just review something, analyze the code, calculate the complexity. So this one can be done on the document itself without executing the code. So the second part, which is executing the code, we have to execute your system. So this part is called dynamic testing, because during the execution, we have two parts, two techniques under these methods. So the first category here, it's black box testing, and white box testing. There is gray box, but it's okay, no need to talk about it. The black box and white box. So in the black box, you will see what's mean the black box. In the black box, today we will talk about these topics, which is equivalence, partitions, boundary value analysis, combinatorial testing, and decision table. And next lecture, we'll talk about these topics. So let's see now what's the dynamic testing first. Dynamic testing, as we said before, we need to execute the application. We need to execute the application. So in the dynamic testing, we have the input, and then we have also the expected result, and then we execute the code and we see the expected result. So, okay, so as I mentioned, we have the both. Interesting to see that. I mean, we have the input and we want to see what the output of that, and then we compare with our expected result. So here also, even we are only talking about the input and the output also, but there is also the internal state of the system also affect the output. So also here, even we don't focus about the internal state, but also it's affect the result. So here the different type of dynamic testing. Okay, as we say now, just dynamic testing, that means we need to execute the code. We still don't say anything about it, about the category under this dynamic testing. So we have now as we see here, we have three types, but in general we have only two types. So we have the black box testing. So what the black box testing, what the white box testing. So black box testing, first, if you see both, we will key in some data and they will see the output. Key in the data and they will see the output in the both. Even we have the gray. So here, you don't know anything about the code. No need to know anything about the code. Okay, but here you should see what's the code. You should test the code itself. So here just you key in the data and then you see the output, and then you compare your output with the expected result. You compare the output of this input, of your input, with the expected result. Okay. In the white box, so from the name white box, then you will see the code, and then you will test the code itself. So this is based on the internal structure of the code, but this is just based on the input and the output. And we have also the gray testing. The gray testing is something is between. Means not all the code you will see it, okay? In the gray black box, some code is hiding and some code is okay, you can see that. So today we'll talk about the black box testing. I hope it's clear until now what's in black box testing. Black box testing, just we key in data and they will see the output. What is the code inside? It's not our business for this type of testing. Okay, so this is the general idea of black box testing. Black box testing. We have the input. We have, as we say, this is the test cases, right? Here in the left side, I don't want to write many things, but it's okay. In the left side, we have the test cases. Here, if you see the input, precondition, postcondition, result. So the result will be comparing with the expected result. if pass, if yes, so it's pass. If no, that means fail. I mean, if equal to the expected result, so pass. If not, so fail. If you see here, you have here the code, but we don't need to see the code. What is that code exactly? We don't know. I mean, it's okay if you don't know anything about the code. And this one, actually, guys, it's called specific testing or specific base. Also, it's called, what is the other words, is functional testing. Functional testing. Why? Because we just test the functional of the application, which is the function requirement. For example, you say this application calculate the sum. So we will key in the numbers, and then we will see the result, which is the sum, and then we compare the sum with our expected result. That's all. So here, this is the function, right? The function of this application to calculate the sum. So we are not interested to see how it's calculate the sum. So this is the general idea of black box testing. In black box testing, we have different type of black box testing, which is all doesn't require implementing or executing the application, executing or implementing. So here we have the equivalent partitions, boundary values, and combinatorial testing and decision table. We will see these one by one. So let's see the first two, because it's not similar, but it's close to each other. So I combine both together. So in equivalence partitions, from the name, guys, from the name, what you see, the name say we have some partitions. So we will divide our input space into partitions. We divide our input space into partitions. So this is the first point, that this case is designed to execute a representative from the partition. Okay. Okay, guys, maybe this is for the, let's see. We have the test cases. Let's say that our example, which is the value from X parameter or X variables, and the value from 0 to 10. 0 to 10. So here, 0 to 10. Here we can divide these test cases, which is, we can say this is the space of, or the ring of these variables. So we divide this into valid and invalid class or partitions. Okay, and then we test our application based on that. So let's see now the first point. We say, okay, the first point we see divide is okay. The second one here, we say the test cases are designed to execute a representative. So now we will execute, we will select one. So like this, now we have 9 to, or 0 to 10. So we have the first one, for example, here, or this it's from 0 to 10. So we have here the first class or the first partitions, the second partition, the third partition. So here will be invalid, right? Invalid. Here valid. Here invalid. Okay. So now we divide our classes or our space, our ring of the parameters of the input into partitions. Then we select one, or we say the test cases is designed to execute a representative. Only we select a representative. So based on your strategy, if you select here, they say it's always 1. So we select one from the first partition, one from the second partition, and one from the third partitions. So from each partition, we select one. And we assume that the result of any, we can say any test case from the first partition, for example, will be same. For example, here is we say this is the minus, right? Because invalid before any number before 0, any number before 0. So if we select -1, it's similar if we select -10, right? This is the assumptions. We say that -10, if we test -1, the result will be same as -1. The same thing if we select any number from here, from 0 to 10, will be same. So the same thing if we select more than 10. So this is the first method of partition or equivalence partitions. Okay, guys. Actually, I say I want to add one slide, but I forget. So before this, guys, actually, why we use, for example, these partitions and why we use the second thing is the boundary. So previously, they just use something we call it random testing. Random testing. Okay, so what is random testing? You see here now, we have this is our search space or the ring of the input, right? Here we divide it into invalid and valid. So previously or before these methods, we have the same thing. We have the ring. We have, for example, from 0 to 10, but we want to test the application. We don't divide it into valid and invalid. Just what we select randomly any number of test cases. For example, I want to test my application with 3 test cases. So I just select randomly 3 test cases. Okay, 3 test cases. I say now our ring, it's from 0 to 10. So I will select 3 test cases. The same thing is here. Here I'll select also 3 test cases. So the problem of random testing, what do you think, guys? What the problem of random testing? And comparing with the partitions testing, what the problem of random testing?
It's not controlled so that you can not guarantee you test all the scenarios.
Yes, exactly. There is no guarantee to test all the scenario. This is also we can say in another word, the distribution of the test cases will not be guaranteed to cover all the tests, all these ring. Why? Because maybe you select, for example, 3, even here 3, but here also is 3. But all these 3 test cases, it's come from this area, for example, because it's random. So there is no guarantee to cover all these ring. So that's why we come with the first method, which is partition testing. Just we have to divide our test or the ring of the input into partitions or into classes. Okay, so this is also the idea of the partitions, equivalent partitions. So here, guys, if you see here, we select only or we divide in the previous example. In this example, we divide into valid, invalid, or invalid, valid, invalid. Right? But you can divide it more than this. You can divide, for example, the invalid into further partitions. Okay, it's up to you. But if you same, okay, there is no further divisions here, so it's just proceed with this. Because as you see here now, for example, is the input. Input, for example, this is the input, which will be valid domain or the valid ring. So, but it's many, not only one class or not only one partitions. So let's see here some examples. So here when we see, for example, we have x, and this x should be between 100 and 200. So here the same thing. We will divide our our ring or our input into partitions. So we say the first partition here, okay, x, it's between which is the invalid one, between 100 and 200, including equals, including 100 and 200 as well. And then we will go for less than, any number is less than 100, and then another partition which is more than 100. If you see, guys, this is exactly what we draw in the previous example. We have 100 and 200, right? So we have the first one, okay, we see which is the valid partitions, which is between 100 and 200, and then the numbers which is invalid, the second partition or the second class, less than 100, greater than 200. And then here we see, okay, also we can also add another partition. So this is based on the requirement, also based on the design of your system. For example, if you don't accept at all the number, I mean, you design your system to not accept, so maybe you don't have to test this. But okay, this is also it's required to divide or to test with different number, for example, with decimal number, with string, with something else. So also this is invalid. And all of them, this also can be divided into further partitions. For example, also we can say, okay, I have one partition related to decimal number, one partition for string number, because the string number also we have many possibilities. So here is the idea is that now we have invalid, valid, invalid. Okay, so this is example of for these methods, which is partition testing. So here, if we have the dates. So if we have, for example, X is accept the work days. So work days means Monday until Friday. So this will be valid. So we come to another one, which is invalid. Here another example where the input accept the true value. So we can divide the input into true and false, as true is valid and false is invalid. So next here, we divide our into partitions. So sometimes, as we say, we assume that the output or the output of one partition, it will be same. For example, if I test, we have this partition, for example, and then I take x1 from this partition and I take x2 from the same partitions, but the result is not same. The result is not same. So in this case, it's better to divide this partition into another two partitions. Divide this partition into two partitions. Okay. Here, if you see here now, okay, for example, in this is okay, but here we take the first value, for example, from this partition is fail, and the second value it's okay or bad. So we have now we say, okay, this our partitions is wrong, so we have to divide our partition into two partitions. This partition should be divided into two partitions, because as the assumption, as we said in the first slide, we say the output or the output of each partition is same. The output of each partition is same, or each partition is under the same category, or each number of this partition, it should be under the same category. For example, all of this here invalid. So that means the result of this should be fail. When we go to the next partition, which is valid, so the result should be bad. So now if from the same partition, it's get the result fail and the result also bad. So that means there is something wrong here, and you should divide this partition into two partitions. Okay, next here also an example. Actually, this is the same example, but here we also select the number. Guys, we say we have now the partitions here. The partition, for example, the first partition, we say when we divide this part into partitions, we say here we have 100, 200, right? And then we say this will be invalid, valid, and invalid. Also, we select also another partition which is not included in this ring, which is also string and decimal number, which is also invalid. So now when we take a number, this is just an examples. The numbers, if you just analyze these numbers, so you see any number from here, we have select anyone. For example, it's less than 100. So any number from this is too small number, and then between this is just example of the input. The one you have to select in your input when you test your application. Here, and then greater than 200 will be any number greater than 200, also string. And then also you can divide some of them is further. This is just example. So here input X valid ring is from 0 to 7. So here also we divide in the same way that we divide this partition. So we have invalid class or invalid partition, which is X is less than 0, and X is between 0 and 7, greater than 0, string, and then we select select the number of these partitions. Okay, guys, in the end, maybe in the exam, I will ask you to divide the partitions, divide the ring of the variables, and then you also give some example. Okay. So it's sometimes difficult to find or divide the ring of your input into valid and invalid partitions. For example, if you have the name or the birthday, so it's really hard if you don't write your requirement well. So for example, for the name based on the requirement should, for example, don't accept the characters, don't accept the numbers, for example, in the name, should not accept the space. So based on the requirement, you can divide or you can identify the valid and invalid partitions. And the same thing, it goes to the birthday and the length of the person, for example.